Today, everyone, we're going to have another video in Julia language programming. So today we're going to talk about the optimization. To be able to write the optimization problem, we need some environments such as GUMP. We will focus only on GUMP. So GUMP is a domain modeling language for mathematical optimization, and currently supports a number of open source and commercial solvers. So we will have to not only GUMP, but also we need to have a solver in this environment. We've got this one. So if I click on this, I will get this page here. So after installing Julia, which we already did, we can install GUMP like using these commands. So I've got this one. So then after, I need to have solvers. There are a couple of solvers we can install. The CLP is one of that. And also, if we have the list of the solvers, Julia package, the Julia corresponding package are in this column. Today, we're going to talk about the linear optimization. Okay, linear optimization for any solver, it's written that LP, if it is written like here, CDD, then it means this package, Julia package, will be able to solve the linear problem. If I click on this one, then I will have probably this guy here. So there's got a couple of information. Installation is like as usual, and the starting point is like the model is like we can write this one, CDDLib here. There are other choices that you can see, CLP and GLPK as well. So LP problem is given here. So MI means mixed integer, equivalent to solve problem type. All right. And if so for here is GPLK. So if I click on this GLPK, I will get this one. So there are some explanation here. It's the same thing, GUMP, and the solver is this GLPK. So to be able to use that, I will do this one here. I will write this one, GLPK.optimizer. All right. So today's time is 2024. 01/28. From here, I will have my name. Then I will have linear programming. Then I will have maximize 2x plus 4y. And from here, subject to, okay, thanks to the Copilot, I can write quickly. And I'm keen to solve this guy here, x plus 4y, 24, 3x, y, 21. Okay, and I will have x bigger than 0, comma, y bigger than 0. Okay, so I would like to have, I'm going to import pkg, and I will have using pkg, and I will have pkg dot add JUMP, MP. So we will wait here. So can see that the installation, I just applied this guy here. All right. So for this one, I will apply this one now. Let's go here. Okay, since I have installed this one, so that's why there was no any lots of changes here. So paste this one so that I will have this one. So no changes because I had already here. And I will have this guy here, CDDLib here. Okay. And this is because of this guy here. Yep. This guy here. So for this one, and we will have, so I added just this one here. Let's have this one only. And we see that now I will write using JUMP, and also maybe I have to write this one using CDDLib. So for model equal to model before writing, so I will be able to write this one here. So thanks to the Copilot, but we see that this is like here, it's given to us already here. So that's why. Okay, so other examples I can see maybe here as well. So this one. Now I'm going to define my variables here. Okay. So let's have our variables at sign. So maybe at sign variables model. So model of this guy here, comma, x bigger than 0. Again, at sign variable. So it's given to me, okay, like this. All right. So now what we want to do is like objective definitely. So what we see that, so the function is like this guy, objective. All right. So at sign objective. Okay. So objective, it's 2x plus 4y because I did it here. So the Copilot understands that I can use. I will write this one, max. So now we want to do constraints. So constraints like this, in case if you don't have Copilot, so what we see that it's like, we can see the Copilot, it's been defined like this, but actually if I search manual like constraints, so we see that I will get this one. So this is here like from this website. All right. So let's go back here. Okay. So I see some examples here. So if I can use this one here and these things, other constraints. So let's use this one here. Copy. Okay. So first constraint is like x plus 4y for y, and it should be 24. So which is like this one here. So what I will do is just copy this one. So I've got 3, this one and this one. So then I will just apply these things here. paste, and if I have this one, this will be just 9. All right. These constraints have been applied when we were defining the variables here. Okay, so to be able to solve this one, we see that the example is this one here, GPLK. So if I find some appropriate example, I will see that. So we need just write this one here. All right, so another example, GLPK is just this one here. So let's copy this one. So let's go here and let's have this one. So, all right, so this is the optimize problem. And we see that, so we can optimize this one. So let's have, okay, so, all right. With optimizer not defined here. So with optimizer not defined. So what we can do is just with attributes. So let's go here. Model. Okay, this one here. So let's see here as well. JUMP. Okay, here. All right, so we need to set the attributes as well. So what we can do is just this. So optimizer attributes. All right, so we see that we can just click on this one, so it will work. So it works. All right. Now we can do this one here. So optimal x. So optimal x equal to, so another one, this one, optimal. So let's have this one here now. So 5. All right. Okay, so we should be able to print this one and actually print optimal x of t x print optimal x. So what we can do is this one, and we can also this one. So this will be 4 and 5 here. Okay, so we can have these things here. So now we can plot the feasible region. So now what we will do is this one, x will be 0, 0.1 to 10. Okay, so so this will work, and this will be plot x. So I'm going to plot this one here. So this will be y equal 24 minus x over, so this will be 24 minus x. Okay, so I should have this guy here. So this will be enough for me, I think. Yep, float. So, okay, so I will write just this one here. Okay, so this will solve the problem. 24 minus x divided this one. Okay, this will be work. So this dot here, so this will be here. Okay, so let's have another of these things. So another constraint. So I will have this guy here. Okay, so I will have this one. So this will be 21 divided by 3x actually. So there is nothing here. So this will be this one here, but we should have like this guy here. So if I have this one, so it will be like these two things here. All right, so we can add like label. Maybe we can add label equal to x or y 24. And we can add this one as well, label equal this guy here. And we can have this one as well. So for 9 minus 5. So we can do this one now. Let's do this one. And let's apply this one. So we see that this is here. And now what we can do is just, we would like to scatter. So I would like to obtain this guy here. For this one, I will add this ln and I will add this one here. So I can, okay, and then this will be, so let's control L here, and this, by adding this one, okay, we see that. All right, so let's have this one, and you see that 4, 5, and this one here. So can I have scatter list optimal x and optimal point here, and we can have this one as well. Okay, so if I have this one, so if I have this exclamation mark, so it will solve everything. So we can have this one here. So we see that optimal point here. All right, so this guy is here. So it satisfies to this line. So this guy is like, the blue one is this guy here. The red one is this guy. It's less than this one, and it's less than this one as well. Now we see that, now here is the thing. We can use this one as well. So you just need copy this one here and paste this one here. All right. So what we can just, it didn't work. Okay, so it's not this one. So let's go and have an example here. So it is this CDDLib, and the example is just like this. Okay, so I can copy this one. I can come here. So let's put back here. Okay, model. Okay, so it's like here, and let's put back this one here. GLPK. Okay, I don't want to use this one. This time I want to use this guy, only this CLD. So if I have this one, okay, so for here, so, and it doesn't give only integer numbers, it gives the float number as well. All right, so this is the way that we use JUMP, and the documentation is given like almost okay, and can find here, you can come and here and see the, for example, GLPK here, you see that the same information is as here as well. GLPK here, and this one is like GLPK here. So you can choose here, or you can just Google and you can get this one. It's the same. All right. I hope you learned something and see you later.